In today's video, we're going to cover low voltage shorts from a heat pump. There's a lot more loads in a heat pump than there is in a straight coil unit. In a straight coil unit, you're using just a contactor. In a heat pump, you have defrost control boards. You have reversing valve coils. You have more conductors that are being energized through the 18-gate thermostat jacket. Additionally, you also have a lot more wires, like I have behind me, that can confuse you. So in this video, difficult look again. You know, how do we take this and take a step back, like looking at a shoelace that's just tied? We know there's nothing complicated about a shoelace. However, the complexities in our head, if we have given up before we even try, before we even start. And so it's not a hard problem once it's well understood. You just have to have patience as a virtue to be able to train your brain and practice getting through low voltage shorts. In today's video, we're going to cover the heat pump side of things, but an interesting perspective that we're bringing now is at the table, where we actually have those components laid out in front of you. Those components can be shorted or not shorted. We show you how the fuse blows. We show you how the meter is catching an amp draw that we're looking for. Different tips and tricks there to utilize in your practices. When we take it to the smart board, we're going to go over it again, and stay tuned. In this perspective, we're going to discuss how to check low voltage shorts, looking at components from a different point of view. One of those points of view is the components themselves. We don't have to look at dealing with this problem in front of a piece of equipment that's very busy, and that, in my opinion, it's harder to learn that way. For us to learn better, we can look at the individual components themselves, and we can apply voltage and understand what that ampacity will be coming off the transformer. I have a lot of components here. I have a relay that we would use for a blower motor to turn it on and off. I have a blower control board that we would utilize to control a blower motor to turn it on and off. I have a fan module that's been taken off of a X13 motor that also has the same relays built inside of it that will turn the motor on and off. All three of these do the same job. They activate a motor. However, you're not going to have all three of these being utilized at the same time. So the reason why we have all three of these is to give you three different examples of whichever air handler you're working on, from whichever timeline, or unless it's been converted back to one of these. We have a transformer. We have a sequencer that you would typically find on a 5 kilowatt heat strip. We have a defrost control board, because in this video we're going to be dealing with low voltage shorts on heat pumps. We have a reversing valve solenoid, the reversing valve coil itself that slides on that so it can shift that valve over. We have the compressor contactor. We have our thermostat, and then we have two different sets of 18 gauge, 8 conductor, low voltage wires. And so when we look at trying to trace down a short, we have to be able to strip away everything else and look exactly at what we have here on the table. And these are identified as loads. These loads will require 24 volts to toggle high voltage to turn on a high voltage component like a compressor, a condenser fan motor, or a blower motor, or a set of heat strips.
So there's a lot of wires that are available inside the unit that are high voltage. There's a lot of wires that are available that are just for low voltage. When we typically look for a short, we don't want to start looking at the wires. We want to start looking at the low voltage components that I have here on the table. Also, I have a thermostat here. It's a load. Okay. There's no display on it because there's no batteries in it. We're going to energize these loads one by one, and I'm going to show you what amp draw I pull off of my 24 volt control side as we energize each load utilizing our SC640 meter. We're going to connect all this, but before we do that, we want to make sure you understand what's in the air handler, what's in the condenser, and the air handler is one piece of equipment, the condenser is another piece of equipment, and why this thermostat is a piece of equipment all by itself. The contactor, the reversing valve coil, and the defrost control board, this is in one piece of equipment. This is in the condenser unit, heat pump. The blower relays, the blower control board, or a fan module, transformer, and the sequencer, which is the heater relay, that's all going to be inside the air handler. So pretty much everything from here this way is in the air handler. Everything from here this way is in the condenser. Two different sets of equipment. One has three components you need to be concerned about because they each receive a 24 volt and a common going back to the transformer to energize them. And then we have the thermostat, which is its own piece of equipment. Okay, the thermostat, the brain box, which is going to take 24 volts from this transformer and it's going to energize back. So we're not going to take wires and just go touching them right away. We're going to start with the basics, the thermostat, and what those wires are for and what they do. What we're going to hook up and what we're going to marry up. Once we wind up taking all these and we energize them and we look at what those amp draws are and how our voltage starts to drop as we start to energize more loads, then we can begin to better understand how we can introduce problems. So we have components that I'm going to put on the table that aren't on here now that actually are going to create shorts because they've been taken out of the field because they've been bad. Everything here on the table is brand new and it has no problem. So we're going to start off with what it should look like, and then we're going to get into what you can look for when you do have a problem with one of these components. We have our transformer wired to 120 volts. Okay, so we're using black and white. I have it wired to this green extension cord. The other two wires, red and orange, are for high voltage. So if I was wanting to wire up to 208, I would use red. And if I was wanting to wire to 240, I would wire to orange. So we are just wiring to 120. So we're using common for white and then black for the 120. So we're wired up here. And we have our low voltage wires just wire nutted off so they don't touch each other because I have no fuse to protect this transformer. I'll unwire these or take these wire nuts off as we start to wire the components up. So first we want to go ahead and let's energize the thermostat. We'll first start off with the thermostat. No float switches, no limit switches are here, no low pressure switches, no high pressure switches. Those are all supposed to be in the closed position for things to operate. They come normally closed. Here we're only talking about loads that have 24 volts in common going back to the transformer. So the thermostat's already been pre-wired. Okay, we're going to go ahead and take 24 volts and I'm going to go ahead and put a fuse in here. Actually, tell you what, I believe I have one made up already. So we'll go ahead and set this over here off to the side. We'll use this wire that's already made up. That should work just fine. And I'm going to go ahead and apply my wire nut just to go ahead and splice this first wire in. And so now we've just extended that wire. Go ahead and get that a good connection here. Okay. And so what we would do is we would take a fuse. And this fuse is a 5 amp fuse. And all we would do is we would go ahead and, this is called an inline fuse. This is how you pretty much put an inline fuse in. Right off the transformer, you would go ahead and tie the fuse in so you can complete that circuit. So we have 24 volts going to this thermostat, but the reason why it's not lit up is because the common wire coming back is not tied into the transformer. So we're going to go ahead and make this connection, and then the thermostat should energize. And that will be our first load. And so now if you can see our thermostat has a display. I'm going to go ahead and just hit select, get through everything so we can get to the actual display that you need to see. And it says it's 73 degrees. We have the fan in auto and the system in off. And so right now we are energized off the transformer. So we want to see a couple of things. One, what is our voltage now that we've taken power away from that transformer? How much voltage did we drop? And so we're going to take our meter. We're going to go ahead and put it on volts. Get my backlight on. And let's just see what our voltage is. And I lost the display there for a second because I untwisted too much too fast. I'm going to go ahead and connect that back, and I'm going to see if I can't just put my lead inside that wire nut. That should work out. Let me get a good connection. And when you're in the field, and as you can see as I strafe that, I don't know if you can see there or not, every now and then you see a little spark. You wouldn't have that. Kind of like when you plug in an extension cord, you know, if the load on the other side is in the on position, you'll see a spark because you're drawing amps right away. All right, so we're going to go ahead and take off these caps off of these leads so I can extend, have a little bit more meat to stick in there. Go ahead and get my thermostat set up. And so what I'm going to do is I'm going to come in here and I'm going to see if I can get in there and read a voltage. Now I'm going to actually come to the top side of this fuse here. And we're actually reading, I'm going to put the backlight back on so you can see that. We're actually reading 27 volts. So we're feeding 27 volts. This is our very first load. Nothing else is being energized here. And so if we wanted to see what the amp draw is, we would come over here, we would hit select so we can get amps. And I'm going to come over here and I'm going to actually clamp this wire. And you see it's reading 0.0, so not much there. We're not really pulling any electricity. We are, but you can't really see it. This is going to change the moment we start putting coils with power on them. So for you to say that I have a shorted transformer, you can see that it really doesn't, or I'm sorry, a shorted thermostat, it really doesn't pull a whole lot of amps. So if you're popping a 5 amp fuse, why would I blame my thermostat for that? I have to exceed 5 amps as a whole number. We read 0, but yet without connecting these, this load has no power. It's like when your float switch opens, your thermostat loses its power. So, you know, and I wanted to start there so you can just kind of understand, you know, that simple sequence You know, I don't have to take all my wires off like I have here now and go through this. I can use my thermostat as a tool to toggle each relay. So the next thing we're going to do is I'm going to come over here with a common wire, and I'm going to disconnect common, so I may lose power on my thermostat for a second. Okay, and I'm going to tie a second common in. Matter of fact, yeah, I'll do them one by one. I didn't lose connection there on common, so I still have a energized thermostat. All right, so now we'll go ahead and test to make sure I have a good connection there on my common by putting one of my leads on the female connector. I'm going to come to the top side of my fuse, and I'm reading 27.3 volts. Okay, so now I'm going to go ahead and I'm going to tie in common to a blower relay. Now I can also read common here because I have a closed circuit. So I'm going to come back, I'm going to put my lead here, and I should still read 27 volts. That tells me my coil, excuse me, let me get a good connection here, 27.2. That tells me that coil is actually good. There's several ways to test your coils out. Alright, so we know that coil is not open and it's doing pretty good. So now we're going to go ahead and take my green wire, which is coming off the thermostat. Don't like that connector. I'm going to go ahead and grab me another one. I'm going to take this green wire coming off the thermostat we typically use to control our relays. Now you're going to hear this relay energize. When we do this, you're going to hear a click the moment I put the fan in the on position. I'm going to try to clean this table off because I got wires going everywhere. I'm going to take this thermostat wire and just set it over here. So we're only coming off the thermostat right now. All right, so we have 24 volts going into our thermostat, past our fuse, common going back. We've put common in parallel to our blower relay, and now we have our green wire, which is coming off of the G on the thermostat over to here. And I want to go ahead and let you know that the moment I put the fan in the on position, you'll hear the relay click. So we'll go ahead and come over here to fan. The relay just clicked. There's a little delay there, not a big deal. But let's first look at the voltage to see if we are still at 27 volts. I'm just going to come over here to my relay at this point. And now we don't have 27.2 anymore. We have now dropped down to 26.9. So we lost a little bit of voltage, and that's the only relay that is energized. So what we're going to do is we're now going to look at what is that amp draw. I'm going to come over here. I'm going to amp out. Try to get this to where you can see it as well without any wires being disconnected. And as you can see here, I have 0.1 amp. So not even a whole amp. All right, I've got to get all the way to past 0.9 before this 0 turns into a 1. Now that 0 on that top has to go to 5 if there is a problem for that fuse to blow. So we're going to go ahead and disconnect our meter. We're going to put it back over here. Okay, fan still in the on position. We'll go ahead and put our fan back in auto. Relay should drop out. You heard the click. We'll go ahead and come back and let's see if we got our 27.2 volts back. I'm going to come over here because everything is common at this point, so I can even come from green to the top side of my fuse. Get a good connection. And I read 27.5 volts. I'll also come over here to common. I read 27.5 volts. That's right. That became common because through the coil, common is energized here. So that means green, believe it or not, it's also common all the way back, even though it's not connected to anything. So for me to have a thermostat that's bad, that means that common is messed up somewhere on my base plate. Because if the hot side was messed up, then things would just start coming on by themselves when the thermostat's not doing that. Most of the time that doesn't happen. All right, so we're going to go ahead and leave this blower relay hooked up. Eventually we'll get to the blower control board and then eventually the module. But I want to keep energizing as many things as possible. I'm going to take this heater relay and I'm going to go ahead and connect a common to it. Okay, and I'm going to go ahead and connect this white wire over here. I'm sorry, that's the wrong side of the relay. Apologize. It was very convenient though, it was right on top. These brass colored parts are the where you'll hook your low voltage up to, as we've had other videos we've released on that. So I'm going to come over here, bend some of these wires. I'm going to go ahead and connect white. Hopefully you can see all this okay. I'm trying to move it back over here on this side. So here's our relay. We're going to come back over here and move this common. I'm going to disconnect commons over here because I got to marry my commons up. Now my thermostat may lose power, and that's okay. I have ours set up to where there's not going to be a delay anyways with what we're trying to do. Okay, looks like I didn't lose anything there. Okay, so we should be okay, and I'm going to test my commons out to make sure I have a good connection. And how I'm going to do that is I'm going to take our meter, and I'm going to come on this side over here, which, yes, it's white. It's supposed to have 24 volts on it when I command it to. And I just want to see if I have 27.5. So we also just tested that that relay is not open. Okay, the coil on that is good to go. So when I energize that white wire, that relay is going to warm up and we'll be able to measure what that amp draw is. Now I'm going to run this in addition with the blower relay because when we do a step process, you want to continue to load up your transformer to see what happens. We're also going to test the voltage and how it drops because we'll have voltage going here, obviously the thermostat and the sequencer. So we're going to come over, we're going to put our fan in the on position. We're going to come over here to mode. Come back to emergency heat. Okay. We're going to crank the temperature up past our set point so we can get a call. We heard the relay click for the blower to come on. Thermostat just clicked, so it's energizing the sequencer. We're going to come over here and see if we're getting 24 volts, and that'll also tell us our voltage that we're looking for. We have 26.4. 26.4. 26.5. And our relay just clicked, so we're closed. And so now let's see what that amp draw is. So we dropped a whole 1 amp from 27.5 down to 26.5. Let's see what that amp draw is. We're going to come over here, we're going to clamp this. And if you look here, 0.2 amps. So again, I would have 0.2, 0.3. So again, not even 1 amp. We still need 0.7 more amps before we can get to 1 amp. And then we have to go through 4 more amps before that fuse exceeds its limit. So if I'm testing for shorts, I have not found any yet. Everything is good. Everything is doing exactly what it's supposed to do. And that's what you're doing. We're just doing a step-by-step process of elimination. I'm trying to keep the table as clean as possible so we have less confusion and everything can be in as plain sight as possible so we don't, get into a situation where it looks just like an air handler where everything's really messy, or just like a condenser and everything looks really messy. But as I add layers of wires on these components, it's going to be hard to keep it clean. So we're just going to leave things and we're just going to keep adding. All right, we don't want to add these two yet, simply because this blower relay is doing the same job as what this will do, and it's doing the same job as what our blower control board will do. And so now I've successfully tested everything inside my air handler. Now it's time to start testing the condenser. So what we're going to do is we're going to take our board and we're going to wire up just to 24 volts. I picked this Linux board because it has lights, so we know when our lights come on, this load is energized. Okay, plus we're going to see what the voltage is. How much volts are we going to lose? Now I have one thermostat wire going over to my air handler. I have to have another thermostat wire going out to my condenser. And so what we're going to do is we're going to take this second thermostat wire, okay, and it's going to run over to my condenser. And those are the 2 thermostat wires that you have. So what we're going to do is we're going to take our yellow, our red, our blue, and our orange, and our white, we're not going to hook it up, okay? There's no need for that. But I'm going to hook up these other 4 wires because they pretty much have to be there. Now once I hook them up, I have the other end. Some of them are already made up. Some of them is going to take them to the board. I'm not going to use this white wire, obviously. So we'll put it back over here. But I'm going to hook these 4 wires up over here. All right, so, and I'm not going to go through in my board and out of my board because I don't want to confuse anybody. I'm just going to energize my board, and then kind of like if you bypass the board, I'm going to energize the valve by itself, and I'm going to energize the contactor by itself, just so we can see that the loads themselves are what we're referring to, not everything else in the cabinet. This is a good way to look at this from another point of view. And so a couple things I'm going to do with a screwdriver. I'm going to back these screws out and start putting some commons in there. That'll make things a little bit easier. I have common here. I'm going to back it out, and I have 3 commons that I'm going to need to put in parallel. And so I'm just going to push all of these into this terminal block. And I don't want to cut, edit, or any of this stuff on what I'm doing here, because you need to see that this doesn't take long to do. And if I can demonstrate that simply in front of you, then that'll give you a little bit more confidence when you're doing it. So I've just married all my commons up, even though one just fell out. I think I have a pretty good connection there. And I'm going to go ahead and put one on my contactor. Okay, and the other one, I'm going to go ahead and put it on one side of my reversing valve coil. I'm going to go ahead and take my red wire. I'm going to leave this yellow and this orange just kind of sitting over here. I'm going to take my red wire, which is 24 volts, and we're going to go ahead and wire it up to the red on the defrost control board. Looks like another one of my comments just slipped out. I need to fix that. It's all temporary, so it's okay to have these fall out for right now. It's not obviously how I would leave anything. Hopefully that stays. Okay. Again, we're not using the whites, so there's kind of just sitting over here. Okay. All right, so we have our reversing valve wire. We have our contactor wire. We're not going to hook those up yet. Over here, I have orange, and I have yellow. I have red. I have common, orange and yellow again. So what we're going to do is we're going to go ahead and marry up our yellow wires like you see in your air handler. It's also a very good video if you're trying to understand low voltage components and how it's all hooked up in the system without looking at a piece of equipment. I have my orange wire. And see, it's just a red through the thermostat, energizing orange or yellow or any of these colors. And this is coming over here, and now it's just an extension going outside. That's all it is. And so you don't want to look at all this as I have a problem with wires necessarily. You know, chances are very slim to have a problem with a wire, although it does happen quite a bit. You want to first check off your loads to make sure you don't have a problem with a contactor coil, a reversing valve coil. All right, so we have common, and we have 24 volts primary that have to be hooked up. So what we're going to do on our 24 volts primary is I'm going to make a connection on my fuse. Let me go ahead and disconnect here. This will, I will lose power for a second when I do this. That's okay. So I lost power on my blower relay and I lost power on my heater relay. And what I'm going to do is I'm going to go ahead and just put another connector on here. Again, this stuff does not take much time. I'm going to go ahead and strip it back. We'll go ahead and take both reds this time, and we'll go ahead and tie them together. We're going to go ahead and put our female connector over both of them. This is how I'm making my connection so they're in parallel. And all I have to do is just, when I'm ready, plug that back onto my fuse. Before I do that, I'm going to go ahead and take common again. Go ahead and get a little bit more wire on that. I'm going to go ahead and take this wire nut off so I don't have any problems. I'm going to go ahead and strip all these back just a little bit more so they can get a better twist around them. And again, this stuff does not take that long. Okay. And now we're going to take all of our commons. Lots of commons. That's why they call it common. We're going to take all of our commons and we're going to marry them up. We're going to take our wire nut. I'm going to begin to start using this as a tool to start twisting these together. Get me a good connection, then I'm going to back that wire nut back off. And another way I could have done this is with alligator clips, but you're not going to see that in the field. So I'm trying to give you a proper perspective. So I use my tool to just twist those together. I'm going to go ahead and strip back on my transformer. And I don't have the best angle, so I apologize about that. There we go. Twist that together. Now I'm touching this, but I'm not getting shocked because I don't have a load, because nothing's hooked up. Now that I've done that, I'm going to go ahead and take my commons and connect them all. Feels like we have a good connection there. That feels pretty good. Go ahead and move some of this out of the way so we can see better. Okay. And you can really feel the heat on these relays. I mean, they're heating up. Okay, so we're going to reconnect our 24 volts. We're going to look at our thermostat. We have a power. The fan and the heater should call here in a second. Our defrost control board is obviously energized. We can see that we have blinking lights now. Okay, we're waiting on that heater relay to energize. Let's go ahead and see what our voltage is right now. Let's come over here between common and 24 volts on our defrost board. .7 volts. We had a voltage drop. Let's come over here to our blower relay. It's going to read the exact same voltage. And if we come over here, we're not going to read anything because the heater relay is not energized yet. The thermostat's in a timer. It just stopped. Give it a second. We should hear our relay energized. But if we come over here, we should read a lower voltage than 26.7. We actually read 26. 25.9 to 26. So you can see that we've already lost a whole volt to a volt and a half. Now let's go see what our amp draw is. What is our amp draw? Now that we have added a third load, or fourth load, load 1, 2, 3, now load 4. We're going to go ahead and connect between our fuse and our transformer. And if you see here, 0.2, 0.3. So when you say my defrost control board is shorted out, that's a pretty heavy statement, because you don't want to just go blaming these components, because you can see they don't really just draw a whole lot of power. Now what's going to really be a game changer on this is when we energize our contactor and our reversing valve. So the first thing I'm going to do is I'm going to come over here and I'm going to take our system and I'm going to take it off of emergency heat. I'm going to go back to off. I'm going to leave the fan energized. You'll hear the relay click as soon as it releases 24 volts on it. Also, you'll see our voltage go up. We read 26 volts. And we'll just check this relay. We shouldn't have any voltage on it. We don't. We come back over here to the defrost control board, and we're now back up at 26.8 now that we've dropped this out. We went up 0.8 volts. We're going to go ahead and connect the reversing valve coil. Okay, so now that is energized the moment our thermostat allows 24 volts secondary voltage to go through it and toggle it. So we're going to come over here to our mode. Okay, we're going to come up here to cool. It's set for 78. It's 72 in a room. We're going to go ahead and drop the set point below the room temperature. We're going to get it to call. And the moment it calls, it's in a time delay for a little bit there. Nope, looks like it's calling. Okay, our reversing valve coil should be energized. So let's come over here and let's just see now. I'm going to come back to the defrost control board and let's see what our voltage drop is. And we're down to 23.7 volts. That was a huge voltage drop. That's below 24. Let's see what our amp draw is. We're going to come over here. We're going to clamp it. And if you look here, we are already above 1 amp. We have 1.3 amps. So our threshold is 5 amps for that fuse to blow. So that reversing valve coil is a pretty big load. So far, it's the largest load out of all 5 that we used. 1, 2, 3, 4, and that's the 5th load now. Okay, now we're not running the heater relay with that because that's not going to ever happen. All right, now we're going to go ahead and we're going to leave that energized, and we're going to come over here because the contactor is going to pull in because it's calling for cool. Let me get a good connection there. And there we have it. You saw the contactor pull in. Let's go see what our voltage drop is now. I'm going to come back to this defrost control board because that's the easiest place for me to put my leads. And I'm wondering what that voltage is. So I'm going to come between common and 24 volts, and I have 23.5. So I'm still pushing 24 volts nominal, which is what we would call that. But let's see what our amp draw is now. I'm going to go ahead and clamp here where we've been clamping. We go and set it up for amps. And if you can see that okay, we have 1.4 amps. And so everything to energize the system and cool, you need a blower relay. You need a thermostat. You need a defrost control board. You need a reversing valve coil, and you need a contactor. And you get 1.4 amps. So when you're in normal operation, it's okay to have a 3 amp fuse. It's okay to have a 5 amp fuse. We're protecting the transformer. If you don't have a fuse, we're not exceeding the ampacity that this transformer can carry anyways. However, as we continue to add load, you'll see the voltage will continue to drop. And the lower the voltage, the higher the ampacity, the higher the amp draw. And so we get to a point to where you can really ruin a transformer because you just have too many loads on it. So you have to step those volt amps up by putting a larger transformer in like maybe a 75 VA. We're using a 40 VA. All right, this is everything in your system for a heat pump. It's a lot busier now. We don't have any problems on the table. I haven't presented those yet to you. What I want to do is I want to go ahead and turn everything off. Helps if you hit the right button. And I am looking at this upside down. There we go. So you'll see that our cool coil will drop out. Our contactor and reversing valve will de-energize. And what we're going to see is our volt amps are now doing much better with those loads de-energized. And our volts are 24.5. So we went up a volt. And what we're using right now is a defrost control board. We're using the fan relay. So I'm going to go ahead and take the fan. I'm going to put it back in auto. And it should toggle that fan relay off because we're not calling for that with the system in off. You just heard the click. And now we're going to check our volts again. And it should have gone up a little bit. And now we're at 24.8. So 24.8 volts. And the only loads that are energized right now are the defrost control board and the thermostat. Let's see what our amp draw is. And we are at 0.8.9 amps. So something is energized more than we thought. So let's go back and see what could be energized here. So our reversing valve coil is still energized. And that's why the coil is causing the amp draw to go up. So I'm going to go ahead and just disconnect our fuse here. That way we don't have that reversing valve coil just sitting there. It's not good to energize these valves or these coils for any long period of time if they're not sitting on the solenoid itself. So we just disconnected that. Everything's off at this point. I'm going to go ahead and take this time to go ahead and energize the blower control board so we can see that as a load. We'll go ahead and take the 24 volts that we have here because we already have a fuse, so we don't need this fuse. So we're going to take this fuse completely out of the circuit. And what we're going to do is we're going to come in and we're going to wire up to where the transformer goes, which is R. And we have to see the XFMR, which we've done a video on this already. So we're going to go ahead and just put 24 volts on that. I'm going to go ahead and just set this back over here. I'll go ahead and move these standoff clips in the front. This way I can kind of tilt it back towards the camera a little bit so you can get a better view of the board. There we go. Okay, we need to put a common wire over there. So I'm going to go ahead and take a common wire. We're going to go ahead and just take the common wire off of the blower relay here, since we're not going to be using that blower relay anymore. We're going to go ahead and take this 24 volts off of it as well. We don't need that. And we're going to go ahead and let's go ahead and just remove 24 volts off of the reversing valve coil. There we go. So when I re-energize it, we don't need to load that back up. I knew that was going to be very brief to show you this. You know, even if I had it on a solenoid, there's no gas in it. It's the same thing. You're not supposed to energize them unless they're in the circuit and they're on their respective terminals. We're going to go ahead and take this common. I'm going to bring this board a little bit closer since I'm running out of room on wires being extended. All right, so now we have just applied 24 volts here, and we want to take 24 volts out. And so if you see here, we got our green wire hooked to fan. We have our 24 volts here. You can see our thermostat's got a display now. I'm going to go ahead and just go through the motion so we can get it back. There, now it says safe. All right, when you have to do that to kind of restore the settings. It looks like I actually lost my commons. So we're going to go ahead and hook our commons back up. Connecting that back. I got a big orange wire nut. I can get more wires in there now. A lot easier. There we go. I hope you can see this okay from your point of view. Again, I can teach you this at an air handler or a condenser where there's a lot of wires everywhere, but then we're going to be looking at a lot of other things that do not pertain to what we're talking about. Okay, so we are fan in the auto, we are system in the off. This is a load by itself, so let's count how many loads that are energized right now. We have our defrost control board. It has 24 volts. It's a load. We have our fan control board. It's a load. We have our thermostat. It is a load. These are the only 3 loads we have. We're going to go ahead and measure what that voltage is so we can see if we've dropped any. All right. Between common and 24 volts, we have 27 volts. So not much of a voltage drop there. We're not going to have much of an amp draw either. We'll go ahead and show you what that is. And if we look here, we're looking at 0. So these are loads. But for you to sit here and say that, well, my defrost control board is shorted, or my blower control board is shorted, my thermostat is shorted. These 3 loads, even though they gave me a voltage drop, you know, they're not really pulling any power. So you need something to really pull some serious power to be shorted out. You know, if there's no, I mean, you could see if this thing was charged somehow, and you know, you would have to literally be making a connection from here to here through the board to short out. Same as here, and the same on my thermostat. It's just not very practical to think that. So we're going to go ahead and come back over and toggle the fan in the on position. We should get a call here in a second. There, thermostat just made a click. We have the board just made a clicking sound. That was the relay on the board. So it's now ready to take power on one end and put it out on the other so we can run the fan motor. We're going to check and see what that voltage drop is. 26.8. Didn't go down that much. Let's go ahead and see what the amp draw is. And again, not really pulling anything. 0 to 0.1. Right? So it's kind of hard to say that these circuit boards are causing your problem. I always say start with the contactors and the reversing valve. That's what I tell most people. And then past that, you'll probably find it between those 2 or within the wire. I'm going to go ahead and let's see what our voltage drop is using this module. Okay, and then let's see what the amp draw is once we do that. So we're going to go ahead and disconnect our commons. Okay, we lose power on everything very quickly when we do that. I'm going to take 2 wires off of here. I'm going to take the common wire off, and I'm going to take the green wire off, which is for the 24 volt call for the blower control board to come on. Now, we had an integrated fuse on there. That's why I didn't put an inline fuse in. Now we have to go back to an inline fuse. Put this over here. So let's go ahead and get our fuses set up. We need to make our connection between here and here, which nothing's going to come on until we connect common, which is our path back. And at this point, we have common and we have green that we can connect over to our module. Now, we had a video that we released on this where terminals 1, 2, 3, 4, and 5, those are all going to be your 24 volt call. So I would take this green wire and I would put it on one of these. That would energize and tell this to run a certain speed. Okay, 3 would be medium, so 4 would be medium high, 2 would be medium low, 1 would be low, and 5 would be high. We have common, line, ground, and this neutral here is just another line. So we're not going to hook any of these terminals up. We're just going to go from common, and we're just going to energize one of these 1 through 5 terminals so we can put 24 volts on this and see what happens here. We're going to go ahead and take and apply. I'm going to go ahead and hook it up to 3, which is typically how you find yours. I'm going to go ahead and hook it up to common. Hopefully I can get a good connection, because typically you have a plug here, and we're not obviously using a plug. There we go. I think that's a good connection. I'm going to set that down, and then we'll wire these commons back up. And the moment I do that, the thermostat should light back up. You'll see the defrost control board light back up as well. And again, you just have to have patience so you can better understand this stuff. Hard to learn something if you can't acquire the patience first that it takes to sit through, whether it's a lesson or you're just trying to troubleshoot. All right, so we have a good connection on common. We know that because without even testing voltage, we have lights on our defrost control board, and we have our thermostat calling. Now it's calling for fan on, so we're already getting 24 volts here. Okay, so at this point, we want to see what our voltage drop is. Put our backlight on. We'll come over to here. We'll go between red and common on our board. We have 27.2 volts. Okay, and let's go ahead and make sure we're getting 24 volts here. I got a little bit of area where I should be able to stick my prongs in there and read voltage if we're getting a blower call. I'm not reading 24 volts just yet. So what I'm going to do, just to make sure that we have a very good solid connection here, is I'm just going to disconnect my green wire. I'm going to stick my lead in there, and I'm going to come back over here, and I'm just going to use common on this side. And so I'm getting 27 volts. So we are getting the call. We're going to come over here and just energize our terminals here. I'm now wired to terminal 5, not that it's relevant. Well, let's see what our voltage drop is. 27.2. So that's real. So we're not really getting voltage drops over here. So for you to say, oh, my module is shorted out, it's the same as saying my board shorted out, my defrost control board shorted out, my transformer shorted out. It's just not a very practical thing. And I wanted to demonstrate that here. We can look at the amp draw. Okay. What is our amp draw? Let's go ahead and connect it to our red wire. We're not even getting an amp draw. See that? But that's a load. That is a load. We're getting like between 0 and 1 amp. Between 0 and 1 amp. Okay, that's not a whole lot. So for me to be able to say it's a short, I have to hit past 5. Does that mean that it's impossible for it to be shorted out? No, it's just not very practical. So I wanted to demonstrate again, you know, not much voltage drops when you energize load 1, energize load 2, or load 3. Now, if we were to take and say, I want my electric heat to be on, emergency heat. There we go. Give it a second, it'll call. That will give us a greater voltage drop. We know that because we already demonstrated that, but we didn't demonstrate it in conjunction with a different blower control or module. There we go. The thermostat just clicked. Let's go ahead and see what our voltage drop is. I'm always coming back to my defrost control board because I'm going to read the same voltage throughout the whole circuit. I am very curious though. What do I got? 26.5. So this heater relay here that we just energized, okay, we can see we have 24 volts on that. It's energized, or 26.6. It is causing that voltage drop. We're going to go ahead and see what our amp draw is. And we have 0.2. So for you to say that shorted out, that'd be kind of crazy too. But when we energize something like a contactor, let's go ahead and look at that for example. We can go back to mode. We go to cool. We're set for 69. Give it a second. Now it says cool on. The contactor just pulled in. Let's see what that voltage drops again. Remember, load, no longer a load. This is a load, and this contactor is a load that are all energized. Let's see what our voltage drop is. 26.4. See, 40 VA transformers all you need. And that's why they don't go to the expense of putting 75 VA transformers in there. Let's go ahead and see what that amp draw is. Now that our contactor is pulling. 0.3. So that contactor doesn't really draw a whole lot. So we're not really drawing a whole lot. But if you notice, when that reversing valve was energized, there's quite a bit. All right, so that's pretty much everything that we have to do here to understand, you know, things that do not possess a problem, what that looks like. Now we need to see what does it look like if we actually had a problem. So we're going to go ahead and disconnect some of these wires, and I'm going to install some components that actually do have problems. For example, I have a contactor here that has a shorted out coil. So let's go ahead and turn this off. We'll see the contactor drop out in a second. Okay, we're no longer getting 24 volts on that. I'm going to remove my low voltage wires on the side of this contactor. And I'm going to put in this other contactor that I know is bad, but we're also going to ohm it out just so you can see what that resistance is between good and bad, to also take advantage of that while we can. Certain things I can't show you on the smart board. Trying to get this wire off of there before this connects out of my defrost control board, which hopefully I didn't just pull that out. Nope, I didn't. So let's look at these two contactors. Good contactor, bad contactor. And if you want to look at the coils, coils look pretty good here. Okay. And if you want to look at a shorted out contactor coil, you can see here that contactor coil, and you might want to blow your image up a little bit on your screen, that contactor coil has got a nice little smoked charge mark going around it. So we're going to see what the ohms are. What is my resistance here, or what is my resistance here? So we're going to come over here to ohms. And let's see what the first one is that we know is good. We have 7.9 on this contactor. Now we're going to come over here to the bad contactor. It's all over the place. .3. Okay, 0.3. I'll turn this off, save some battery power. And so we're going to take our good contactor. We're just going to move it over here with our blower relay that we're not using anymore. And we're going to see what happens when we take a bad contactor coil and we energize it, okay, making sure we're not calling for cool here. I'm going to put common back on the side of it. I'm going to take 24 volts and I'm just going to kind of hold it there so I can release it so I don't blow a fuse, because I have many fuses that I can put in here, but you know, I want to show you how to do this with amp draw so we don't blow a fuse. Okay, so we know everything else is here is good. We know our wires are good. All these loads are good. Let's go ahead and put their thermostat, using it as a tool to give us 24 volts everywhere. Let's put it on cool. We'll get it to call. Looks like it just called. Okay. And we know we have 24 volts. The moment I put 24 volts on the side of this contactor, because we don't have the right resistance, you know, it's going to be a direct short. We're going to pop our fuse. And I may not be able to stop it in time. So I'm going to try my best to try to get my amp draw ready. So let me go ahead and just put the meter in position. I'm going to utilize the table here to get the wire to pretty much go through my clamp. You know what I'm going to do? I'm going to go ahead and take our fan and I'm going to put it back in auto. We're going to go ahead and disconnect our common here. We're going to go ahead and disconnect our green for our fan call. We're going to take this module. We're just going to set it over here out of the way. And I'm going to try to get this meter in here where we can actually read a good amp draw. And so I can simplify being in two places at the same time, because I'm not going to be able to touch this and be over here to show you this. So we are set up. We got our wire, our 24 volt wire going through here. Where if we exceed 5 amps, if I don't catch it in time, I will blow this fuse, which we have another one that we can catch. So I'm going to go ahead and put this on volts. I'm going to go ahead and hit my select button, put my backlight on. Okay. All right. All right. We're going to go ahead and We're calling for cool already. The moment I go to touch this, we'll probably see a spark on the side of my contactor. Don't know what the contactor coil is going to do. We're looking for this amp draw here to jump, and if I don't catch it in time, we will blow a fuse. And here we go. What did we see? Let's try that again. And it looks like we lost our call for cool for a second because it was such a high amp draw. It actually dropped the voltage, and the thermostat went into a reset mode. But electricity is fast, so you don't really see this, and that's why people get frustrated, because they have a hard time seeing what's going on with their shorts, because by the time they have an opportunity to get everything connected, they're not, and they can't see everything in real time like we can here. And so our thermostat is got the cool on flashing, okay? And what we're trying to do is we want to wait for it to call. I'm going to touch the side of the contactor again, which it just called, so I have 24 volts right now. Let's put our backlight on, and let's really pay attention to what this amp draw does. Now, we caught it in time. I released it in time, so we saw the number flash, but I didn't pop my fuse yet. All right, let's see it again. Thermostat lost its voltage, and what happened was this fuse did not pop. So sometimes these fuses, they just don't pop like they're supposed to. So what we're going to do is we're going to go ahead and just disconnect. We're going to take another fuse. We're going to put another fuse in there. Okay, cool on is flashing. Give it a second. It'll call. We'll see what that amp draw is. Our fuse is either going to trip, or I'll be able to release it in time. We can see that amp draw shoot up. It's another way to skin a cat too. I'm going to go ahead and make my connection with a female connector. So another way I can do this, I can take 24 volts directly from my transformer, and I can just energize this here, which is exactly what's coming through, and I don't have to worry about these time delays and the thermostat reset and all that. So we can go ahead and do that very quickly, and we can just simply take this out. We don't need our defrost board anymore to do this. We're still in parallel here on common, so I can apply 24 volts directly to this contactor coil, and we can experience that short very quickly. So the moment I do this, we're putting 24 volts. You can see the fuse here. What we're trying to do is we want to blow our fuse with a known shorted contactor coil. I'm going to see if I can't touch it so we can see the amp draw. Let's see what that got up to. I'm going to try that one more time. We didn't blow our fuse. I caught it in time, which is my goal. What if you're way out in the middle of nowhere and you have no more fuses but the one that's in there? All right, we're going to try it again. You see how that shot up? We're going to try it one more time. And it popped. And I jumped. So let's go ahead and look at that. You can pause that video right when it blew, and we have a blown fuse. And so if I was looking for my short, and here you are, you're just, as soon as you put the fuse in and you get a call for cool, it's blowing. Start checking the things that happen during a call for cool. Is it the reversing valve? Is it, a coil? Is it the contactor coil? Isolate your problem by isolating the component. And that's all we've done. We started off with just a thermostat, and we slowly wired the whole system up. And that's pretty much what you have to do. You have to disconnect everything and then slowly wire your components back up. You're going to have to take time. But I'm not sitting here searching through a bunch of wires and messing with float switches and messing with limit switches and messing with low pressure switches and high pressure switches and any other defrost sensors and all that. I'm not sitting here trying to say it's a circuit board that's bad or a thermostat that's bad. I'm not trying to say my transformer's bad. I'm not saying blower modules are bad or blower control boards are bad. I'm going right to what could it possibly be. All right, let's look at the things that carry the most amp draw when those loads energize. The reversing valve. Okay, let's go ahead and disconnect it. The contactor coil. Let's go ahead and disconnect it. Now we put out a shorted contactor coil. I showed you the high amp draw, and we blew the fuse. I blew the fuse on purpose. So you don't want to just try to chase your shorts down by going through fuses, although you can do that too. Maybe it's faster, but it's just as fast to do it with a meter. So what we're going to do is we're going to come back and we're going to put another fuse in here. I'm going right to my source, okay, where I know my problem is. Let's look and see what that amp draw is. I'm going to try not to blow my fuse this time, and I want to see what is that amp draw. And I blew my fuse. That was fast. And that got up to 6 amps. I believe that got up to 6 amps. Well, it's a 5 amp fuse. You exceed 5 amps, you're going to blow it. You're going to blow it. I'm going to put a 3 amp fuse in here just to show you that it's the same thing. I have a blower control board over there that has a 3 amp fuse that I could use because I don't have one on the table. So I'm going to go ahead and replace this one, because you might be asking yourself, well, it had a 5. Can I put a 3? You can. If there's no problems, I've already demonstrated that you're not going to pull more than 1.5 amps anyways. I'm going to go ahead and I'm going to have to replace these batteries here in a little bit. But we're almost done with this demonstration. All right, we're going to come back, put it on selection for amps, put the backlight on, and we're going to go ahead and put the 3 amp fuse in circuit. Because if that's all you have left, go to the 3 amps. Once you solve your problem, you can leave a 3 amp in there. All right, so let's go ahead and see what we have now. 3 amps is going to blow a lot faster. I'm going to have to be a little bit quicker. Let's see what we get again. See what we get again here. Yep. Don't know what that amp draw jumped up to. Looked like it might have been 6 again, but that's more than 3. And we're dealing with whole numbers here. All right, so we're going to go ahead and turn the meter off, give that meter a break for a little bit. I'm going to leave this connected here. And let's just say we had some bad wires. What would that look like? So I've got a couple of cables here that are bad. Now I'm going to go ahead and just get rid of some of this stuff that we just don't need anymore. I'm going to go ahead and get rid of some of these wires that we don't need anymore. I'm going to go ahead and take our our heater relay. We're going to go ahead and take it off. These connections hold on pretty tight there. I'm going to go ahead and clean some of this off over here and just kind of move some of the stuff out of the way that we just don't need anymore. All right. I'm going to take this contactor out of here because we know it's bad. So let's just get down to what a wire will do if it's bad. So we're going to go ahead and disconnect our bad contactor. Let's go ahead and get that out of here. We don't need this reversing valve. coil anymore. It served its purpose in today's video. We're going to go ahead and get that out of here. What else do we have? We don't need this blower control board. Let's get that out of here. We don't really need this thermostat either. So what we're going to do here on this thermostat is we're going to go ahead and disconnect. Looks like what I can do is I can actually disconnect this defrost control board here. Let's go ahead and get that out of here. What else? Let's go ahead and disconnect 24 volts itself. Before I do that, let's go ahead and put that back on that common so they don't touch. Go ahead and put a cap on that so that doesn't touch anything. Okay. And we're going to go ahead and take this all out of here. We don't need that anymore. Clean this table up a little bit. We got a transformer. Let's look at some thermostat wires that we know are bad. Okay. If you look at these thermostat wires, we can quickly identify which one would go to the outdoor unit by the one that has green wire wrapped around it. That's typically going to be the one that we use for our condenser. The one that is using more conductors, okay, where we have brown and black wrapped around it, typically that is going from the thermostat to the air handler. So we would go from where the T-stat was to the air handler. We would marry these wires up here at the air handler, and then this would go back out to the condensers. And that's it. And then the wires that we need in the air handler are going to be, we need 24 volts coming off the transformer. So we're going to use red. Okay. And we're going to need common. Okay. And so what we're going to do is we're going to take our our wires, and right now they're not connected to any devices. And this is how you kind of have to set yours up. You need to just disconnect it from everything and let's test the wires out. The first time we tested the wires out, we did it because nothing else was a part of it. So we energized everything little by little. We're going to do that same process again, but without the components. All right, so we have 24 volts that is going to go on these two red wires. Obviously, this red wire here, it goes to the thermostat. Through the thermostat, it's going to energize all these other wires. Then through this end, it's going to make up 24 volts to the relays through wires or at the air handler through the wires at the condenser. So if we were to take and just put 24 volts on here, there's no load, so we should not have an amp draw. We should not blow a fuse. There are no loads. There are no relays. There's no boards. There's nothing on these. So why should we read an amp draw? So we have to test the wire out, because if we get an amp draw, then we're shorted out somewhere to common, going back to the transformer. So it's very easy to test these wires, but the only way you can test these wires is to literally disconnect them, because the moment I have them the moment I have these connected to something, like a contactor, for example, if my contactor is bad, I might accidentally say my wire is bad. No, disconnect it from everything and then test your wires out. That way you can say my wires are good to go. And so this is the only way to test the wires out. All right, so what we're going to do is, we're going to test these one by one, little by little. And, we can just kind of touch them to everything. So we're going to make sure they're all separated, not touching each other, kind of like I've done here. And I'm going to do that on both ends. Of course, this would be at your equipment. And an easy way of doing this, and I'm going to show you a little trick, okay, is you can take a wire nut and you can just cap off. I can cap off my common over here. Now all these can get hot, 24 volt hot, and touch each other. It's not going to do anything as long as nothing touches common. So I safed off my common. Over here, I don't have to safe off my common because I have a female connector on it. Okay. Over here, I have safed off my common by putting a wire nut on it. Okay, and so let's see what happens when we start making the connections with our amp draw, because we're going to do it one by one. We're going to take some wire nuts here. All right, and the first thing we're going to do is we're going to tie all of our commons together first. Before we do anything else, we want to go ahead and tie all of our commons together. That way we create a path back to the transformer. That's why we're doing that. So we already have an orange wire nut over here for our common. And now I'm not trying to ohm anything out. There's ways to do it that way too, but I'm trying to save you some time. Just make a disconnect and make a reconnect. All right, all my commons are tied together. Nothing's hooked to any load. There's no loads on the table. All right, so if I get an amp draw, it's because something's touching. All right, so now the next thing we want to do is we want to go ahead and just take and make sure we have a fuse so we can protect our transformer. All right, I'm going to make up a couple of connectors so we can put a fuse in there. Okay, we're going to go ahead and grab a fuse. It's not blown. I got blew quite a few of them over here. I'm going to go ahead and, there we go. I'm going to go ahead and connect one side of it. Now the other side, I'm going to go ahead and put two different connectors, one on one, so I can energize them independently. Okay. See how I want to do this. Another way of doing that is I can just make a connection where I just strafe them together. In order to do that, I would have to run a third wire back over to here. So what I'll do is I'll do two independent connectors. Now you're obviously not, you're just going to touch your wires together, but I have to do something a little bit different on the table here. Alligator clips are also a very good way of doing this, and I can also show you with alligator clips. Maybe that's not a bad idea. So I'm going to go ahead and grab an alligator clip. Let me take one of these wires over here, strip it back. I'm going to go ahead and take this female connector. I'm going to crimp it on. I'm going to leave it kind of on this fuse the entire time. And now all I have to do is literally just strafe it. And I'm going to do this with a set of alligator clips. So now notice we have our meter on here still. So as soon as I turn it on and I do this, we'll start to load everything up. So we're going to take an alligator clip. We're going to go ahead and clamp it on. Okay. And what we're going to do is we're going to go ahead and take, and we're going to test red out first to make sure red is not touching common. All right. Now, if red is touching something else, you're just going to energize a load. But if you're touching common, you will blow the fuse. You will blow the fuse. So let's go ahead and come over here to selection so we can get our amp draw. And I'm just going to strafe it. So all I'm going to do is strafe it. And we have nothing. Strafe this one. And we have nothing. So at this point, we can actually just clamp it on there. And I know this red wire is not touching common. I'm going to go ahead and clamp it on this one. I know the red wire is not touching common because I have no amp draw. And I didn't blow my fuse. All right, so we're just testing the wires out. All right, now let's go to O. I'm going to strafe it. Oh, we got an amp draw there. We got an amp draw there. Looks like we have a contender for a short. All right, we're going to go ahead and skip past that. I just want to test some more of these wires out. Let's go ahead and test out, let's test the O out on the thermostat side. And I got nothing. Let me go ahead and put my backlight back on so you can see that. I've got nothing. Let's go ahead and test green out. Nothing. Let's go ahead and test yellow out. I've got nothing. Let's go ahead and test yellow out over here. I've got nothing. Let's go ahead and test white out. I've got nothing. Let's go ahead and test white out over here. I've got nothing. Now let's go ahead and test that one that we got an amp draw out of. Was this orange wire going to the outdoor? Here's the other end of it. Here's the other end of it. Let's test it out. Ooh, see that spark? That amp draw is pretty high. Now what happened if I left it on there? What would happen if I left it on there? Ooh, we blew our fuse. So rewind that so you can see what that amp draw is. It was obviously past 5 amps for us to blow a 5 amp fuse. Not one load. No reversing valve coil was on that. No boards, right? Because those boards aren't a problem anyways. It was just the wire. So let's inspect this wire. What could it possibly be? Well, I don't know, but I know I have other conductors. So some of these other conductors that we're not using, we need to test them out. We lost one conductor going outside. You have 3 more conductors. So let's go ahead and let's see if we can use this brown conductor. All right, I'm going to go ahead and unravel it. I've got brown, I've got black, I've got green. Let's try to use some of these extra conductors that we're not using for anything else going out to our condenser. Right? Because going out to our condenser, we only need 5. Going to our thermostat, going back to our air handler, you need 6. All right, well, you have 8. So I have 2 spare wires from my thermostat to my air handler, and I have 3 spare wires going from my air handler out to my condenser. I'm going to wrap these back up, get them out of the way, keep everything as clean as possible, less confusing for the next person. Because when they're tucked and wrapped around, it literally looks like they're good terminals. But if I had everything stripped all over the place, it doesn't look good. I would probably take this orange and not wrap it up so somebody knows, ooh, they're not using that, they're using this, and the other ones must be good. And, it's kind of like a universal code where we can communicate, what happened. That experience will allow somebody else to better understand what was going on in that cabinet earlier when somebody else was working on it. We're going to have to change out our fuse because we blew our fuse. Here's our blown fuse. Good thing we got more. But we're trying to test out with amp draw so we don't lose a fuse. But for this purpose of this video, I'm trying to show you in the event you didn't see that amp draw that, yeah, that fuse block or fuse blew. Let's go ahead and get a new fuse in there. We can read our amp draw. A lot of people don't know this trick on this meter where they can read amp draws on low voltage. All right, we know everything's good, right? We know this orange wire is not good. Let's see if this brown wire is good. Brown wire is okay. There's no amp draw. Let's go back to that orange wire again in case that customer needs to understand, hey, that orange wire is bad. Let's be transparent about it. Check this out. Oops, it's bad. Got above 6 amps. Fuse blew. Protected your transformer though. Another blown fuse. And so now there's another type of short that I want to show you. And it's a short that does not lead to a fuse blowing, but it does lead to a device running. So a device running. So let's say I had a contactor, a good contactor, and I was using this for my, say my heat strip. And my heater relay was this contactor. I'm going to go ahead and connect common over to, actually I can actually just connect it anywhere, however I want. Let's see here. Let's go ahead and connect common. And let's go ahead and connect tell you what, let's go ahead and connect I already know that I got a bad white wire. And how I know that is because I created the fault. I slid the jacket over, skint it back, put the jacket back over, but you can't see that. Somewhere in here, these wires get bent and twisted, and it's not good for that to happen. It can happen across your attic, people stepping on it and all that, and things can just touch and energize. I want to show you that you can energize a wire just like you do through your thermostat without a call, and that's how things run when they're not supposed to run. And so I'm going to go ahead and hook one of those wires up so you can see that. And so I'm going to go ahead and say that when I connect actually, you know what? I don't have to connect it on this end. I'll just connect it on this end over here. Crimp that on there. I'm just going to plug this into my contactor now. There we go. So that's plugged in. Let me go ahead and see if we can get all the way back over here. We can read an amp draw. We're ready. I'm going to go ahead and touch red, okay, over here. There's no problems. That's going to my outdoor unit. But when I put 24 volts on my thermostat, even though there's not a thermostat here, check this out. So we're putting 24 volts on a wire that is making a connection in the jacket, and I could have the wrong wire too. Let's go ahead and test out the other one. Helps when you have a fuse that works. I forgot that I blew that. Grab another fuse. So there is a connection inside that jacket where red and white are touching, and I know that because you're supposed to know in a lab where you're creating your faults. Let me go ahead and take my alligator clip off of there, connect the fuse back. There we go. Set it up so you can see the fuse. Put it back over here. See what kind of amp draw we can get. All right, I'm going to touch the red wire, and even though there's no thermostat over here, because it is making a connection inside the jacket, it is shorted to the white wire. You will see the contactor pull in. And so let's just say that was a heat strip. We're not pulling much amp draw, 0.2. So there's not a problem with that. You don't want to say, oh, I got a bad heater relay or something like that because it's energized. Well, I pulled the thermostat off the wall, theoretically here. There's no thermostat here. So how is this being energized? All I did was I connected red. And so that's the other type of short that we can find, where wires are just energizing, and you can have relays just toggling on blowers and heaters and compressors and reversing valves not being energized or being energized. You know, there's just wires can make a disconnect, so you have to replace them because you're not getting power there. Wires can be touching inside the jacket where it's shorting, or when I say shorting, it's energizing wires that should not be, like the red is energizing here. How would I fix that problem? Very simply, I have a black and I have a brown conductor that's not being used. I would swap out for another conductor. That's as simple as that. And so I know the relay is not the problem because, you know, the relay is not energized anymore. And so that's the other type of short that you can have. Pretty much all I need to go over from this perspective. We're going to go ahead and take it to the smart board and match this stuff up, talk about the equipment and, you know, a step process. We covered a few steps here. We covered, hey, can I just blow a fuse? Can I measure ampacity? I can't show you the ampacity part on the board. I can just kind of explain it a little bit verbally. So this was a very good perspective on that note. And also I can't show you how fuses just pop on a board, where I can actually physically show you this in this lab experiment here. So we're going to take it to the smart board. Stay tuned.
All right, that table perspective was pretty neat because we took away the entire air handler. We took away the condenser. We gave you no wires other than the ones that we needed to hook up exactly to our key components. The key components that I'm talking about are the ones right behind me. All right, transformer, fuse, defrost control board, sequencers, reversing valve coils. We even wired up the blower module. We had a 9380 relay, a contactor, thermostat, and a blower control board. Now, 3 of these components you're not going to have all in one time, and that would be the blower relay, the blower control board, and the X13 module. You're not going to have all 3 of those. You're only going to have 1 out of those 3, but you might have a different air handler that's using this board, or an air handler that's using this relay, or one like it, or you're just using the X13 motor module. Okay, so we gave you a perspective to see what would our voltage drop be the moment our transformer starts loading power up on all these components, and what was our amp draw as we were losing voltage, that our amp draw go up, and how high did it go up. And we started to look at the contactor and the reversing valve coil gave us the most value on ampacity. We had the highest value when these were loaded up. This one here and this one here. It's hard to show you that on a board. I can talk about it, I can draw pictures, I can show you images, but I can't show you unless we actually apply power in a controlled environment and test that out. And we got to do that, and that's really neat, and I didn't have to confuse you by doing it inside of a piece of equipment that has a lot of other wires. And what I'm talking about is right here. And I want you to look at this, that it's not difficult, so I have it down as look again. If I were to look at this, what possibly could be shorted out? You may say this whole thing needs to be wired again. Is it messy? Absolutely. Very messy. Okay? But at the end of the day, if I looked at this confidently, I'm going to say, you know what? Let's go ahead and go right to the thermostat, or I'll go over here to my thermostat control wires, my red, my orange, my white, my green, my yellow. And I'm going to sit there and put 24 volts on each one of those and see which one of these relays that pulls in is causing a high amp draw that would blow my low voltage 3 or 5 amp fuse. And eventually I'm going to isolate the key component like we were on the table. And then I'll replace that key component. Now, as I start to put power on these, I may experience a problem with the wire. Most likely I'm not, Because what came in here and got messed up, I don't know, I don't think anything could have. But if I have a wire, like a low voltage thermostat wire, I'm going to show you real quick, that's running outside of the cabinet, okay, from a thermostat to the condenser, or from the condenser to the air handler, whichever, you know, a rodent can chew on this, a weed eater can hit it, right where it comes out of the ground. It goes across an attic, crawl space, somebody could put a staple on it, staple's too tight. This could have already been bent up and twisted and come off the roll, defected, where some of these conductors just aren't very good. I showed you at the table how some of these conductors can be touching a hot conductor and just energize a relay. I also showed you how, you know, you can simply just be strafed back to a common, back to the transformer, which is like a neutral, and that will also cause a short. So I'm not going to assume that that is what's going on here until I have already eliminated the possibility of having a bad coil, because coils go bad quite often. And as voltage starts to drop, we don't get proper voltage on these coils, we can hurt these coils. All right, so sometimes we don't have the right transformers to begin with. I guarantee you we're probably going to have more than a 40 VA transformer on a piece of equipment like this. Most likely it's a 75 VA transformer. So as we start to, you know, drop voltage, we can handle that power that is required for all of these to pull in. We showed you on a 40 VA transformer. So yes, this could be a problem. Most likely these wires in here aren't. So don't look at this complex like a knot and say, oh, I don't have time to untie it or deal with it or figure that out. You know, step back for a second and deal with the components. And it's very easy to do that. We're going to go over here and we're going to play the matchup so we can better understand these same key components. And there are no wires on this, right? So we're going to just start connecting dots. First, what is inside my condenser now that I'm dealing with a heat pump? Okay, now that I'm dealing with a heat pump, okay, let's draw some arrows. I know my defrost control board, that's inside my condenser. I know my reversing valve coil, that's inside my condenser. What else is inside my condenser? Not the transformer, not the fuse, not the indoor blower module, not the indoor heat strip relay, not the indoor blower relay, not the indoor blower control board, not the indoor thermostat. Okay, maybe the compressor contactor. And so when you start to simplify it, if I have shorts, I have 3 key components that I need to test out before I start going anywhere else. Now, it's no longer complicated. So what we're going to do is we're going to switch the colors up, leaving those colors there. Let's go ahead and go to, let's go ahead and use, we'll use black. Let's go ahead and see what's going to be inside this air hammer. All right, well, my transformer, well, that didn't come out right. Let me go ahead and make sure I'm on the right color. There we go. My transformer's inside the air hammer. My heater relay, that's inside the air handler. This blower control board, that's inside the air handler. And if I'm using this, I'm sorry, not blower control board, blower relay. And if I'm utilizing this blower relay, then I'm not using this blower control board, and I'm not using this X13 motor module. The fuse is part of the transformer. We're going to go ahead and just draw an arrow in here as well. And so, very simple. I have 3 key components inside my air handler: heater relay, blower relay, and the transformer, right? And I have 3 key components inside my condenser, 6 key components. All right, well, if you look at your thermostat wire, okay, that's controlling all this, let's go ahead and do a little bit of erasing, okay? And let's look at those 6 total key components. You have to simply look at this so you can simply understand it and simply get through your problem. All right, let's go ahead and write out everything we're going to need. Okay, let's go ahead and use the color red because everything is an extension off of red. So we have red, we have Y, we have O, we have W, we have a G. Okay, there is another conductor that we are using here, okay, that is not energized, but it's a common. All right, so notice I've left all these one color and then I said common. All right, well, looking at that, common, path back to the transformer, red, path away from the transformer, both of them coming from the air hammer. Here's my transformer. Let's go over here to black. This is inside the air hammer. Okay? So the transformer's in the air handler. The transformer is putting 24 volts out to the thermostat. Because we have a path back, we now have a display. So everything else is an extension off of red. So red to Y. What does that do? Okay, well, let's look here for a second. All right, this contactor, it's found inside the condenser. It tells the condenser to come on. So the condenser fan motor is running and the compressor is running, right? And so what does it need to do that? Okay, so we're going to go ahead and we're going to use yellow, and we're going to say this points right here to the condenser. All right, so low voltage here, contactors in there. All right, what's next? O goes to the condenser. Okay, well, guess what else is in the condenser? The defrost control board and the reversing valve coil. Those are my three components. All right. Now, do I have 24 volts in common coming from the condenser? I absolutely do. So let's go ahead and say that 24 volts, like it comes up here, it also comes over here to energize that defrost control board. We have defrost control board videos. Look at them. They're all on this channel. Now let's take our common and let's give a path back to where our transformer is. See how that works? I've got W and I've got G. Now we're going back to the air hammer. Okay, let's look at W. Here's my heater relay. Let's draw an arrow. It's inside the air hammer. Okay, well, what does it need? Okay, well, the thermostat has to give 24 volts, which I like to use the color purple if you've seen my other videos, coming off of W, right? It's inside the air handler, so we're going to say 24 volts comes in here, the components in there, right? And now we have to, common's already in there, so this has got now 24 volts on one side, common on the other. Watch the videos for heat strips. We talk extensively about that. Let's go to another component, the blower relay. Let's go ahead and take this, let's draw an arrow. Guess what? It's inside the air hammer, right? Those are the three components in the air hammer. These are the three components that are in the condenser. 6 components, 6 sets of wires on the T-stat. Let's go ahead and take our green, because red to every one of these is an extension. This is going to be going to the air hammer. Put our arrow in here. And so we've covered all of our components. It's very simple. It's a match. Now the ones that we're not using, we're going to go ahead and come over here and we're going to say we're not using this module. We're not over here using this blower control board. So there we go. Very simple. And so again, the thermostat, okay, the brain box, all right, it's calling all the shots. It can't call a shot. It can't do anything because it's just lending power from R to each terminal. And then it goes in the direction that it needs to go in. All right, so if we looked at this any further, it's not going to change. All I would do is I would just change out this one relay, okay, with a blower control board. Or I would change out this blower control board with a module, okay? So let's erase this and let's look at this another way. There's another way of learning. This is one way of learning, right? There's another way of learning. We're going to cover that. The way you need to be able to identify these key components are, this thermostat is R. That's it. Don't look at it any other way. It's just R. Everything else coming from it, it's taking R and it's energizing it. So we come over here, let's put an R here. 24 volts. All right, start looking at this air handler as it has R, it has a common, it has a G, and it has a W. That's it. And let's look at our heat pump a little bit differently now. It has to have an R, it has to have a C, common, all right? It has to have a W to energize the heat strips in case it's during defrost. Watch those defrost control videos. Talk extensively about that. It's got to have an O for the reversing valve, all right? And we have to have a Y call, right? So we can have a contactor pull in. That's it. That is it. Okay? And so we're not missing anything. Now we can now look at these components here and we can memorize them a little bit better. We can now say that I'm on Y, so I'm going to use yellow. This defrost control board, okay, I'm now going to identify that as Y. Let's look at the reversing valve coil. I'm going to identify that as O. Okay, again, you know where they're found. Okay, I'm going to identify, matter of fact, I'll use white so it may show up. I'm going to identify this sequencer here as my heater relay as W. And if I'm using this as my blower control, I'm going to identify that as G. Okay, and if I'm not, let me do this. I'm going to stay on that color. I'm going to put an X here. I'm going to put an X here because we can't use them all. All right. That's contactor over here. We're going to go ahead and go back to Y. Now you notice I put a Y over here on that defrost control board. The reason why is I've got low pressure switches and high pressure switches and Y out. All of that in that board is taking calculation during heat mode of the call for Y. Right? Yes, theoretically I could say that that is R in C. Okay, not to confuse anybody there. But that's it. Let's just look at this a different way. Let's look at this a different way. If you can identify your key component very quickly with the color wire, okay, like we've used colors here, and if I can identify my piece of equipment with a color wire, then I have now simplified the understanding of you know, this isn't that complicated. This isn't that complicated. It's just really not. And as you can see here, I've got G here. I don't have it anywhere else. I've got G here. I've already put the part in here. Let's just say that I'm not using this, okay? And we're over here, and I'm using this module, okay, like you probably are in today's age of equipment. There's my G. Not using the blower control board. Okay, I have to identify that module. That's a G call. That's a W call. That's a Y call. That's an O call. That defrost control board has got 24 volts on it. Probably not going to have a problem at all, but you know what? It's really doing everything with Y more than it's doing anything else. It does release power on O and it provides power on W. Watch the defrost control videos. It does a lot of things. But if I'm talking about a short, let me go ahead and identify these a little bit differently so I can quickly get through that short. What's another thing we can do? We can do the step process. We talked about the step process in the last video. The last video we said we had 3 steps. The first step you need to do is, and I'm going to go ahead and leave all these here so I don't have to rewrite that because it's already a long video as it is. Let's go with, if I said step 1 on a heat pump, okay, should be R and C. Everything that's R and C, only R and C, okay, that would be the thermostat. Okay, what else? That'd be the defrost control board. What else? I think that's about it. If you are using this as a blower control, and we don't have a, let me put green back over here. Say we're going to put an X there because we're not using that. And we are using this blower control board. Then guess what? I'm going to go ahead and put a G here so we can identify that as G. But guess what else it is? It's got an R. It's got a C. Just like at the table we showed you when we put 24 volts here, 24 volts here, and 24 volts here, because those are 3 loads because they require 24 volts. Guess what? Didn't really hurt our transformer, didn't have voltage drops, we didn't have any issues with drawing amps or anything like that that we could even measure, like 0.1 amps in combination of all 3 of them. That's nothing. So first go ahead and test that, because guess what? You just eliminated 3 components. You just eliminated 3 components. You eliminated one, let's see here. You eliminated 1 component in your air hammer, 1 component in your condenser, and you've eliminated your thermostat. So you're already checking the boxes. What's the next thing you can do? Let's go ahead and look at number 2. Okay, now we can refer back to the first video I released on shorts where we said step 1 is the G call. Okay, that's right there in the air hammer. Okay, so now we can say, hey, you know what? Fan came on, didn't short out, didn't trip a fuse, and we did not get an amp draw that exceeded the amp draw rated on the fuse. So looks like that's good. What's the next thing we can do? All right, on the first video we went to W and we went to Y, right? Well, here we got a little bit more than that. We have Y, O, and W. If you're in cooling, you don't really have to give it a W call because it's in the middle of July or August or September, whatever month you're watching this video in. If it's winter time and you're watching this video, heating cycle, yeah, definitely check W. So we're not going to eliminate it. We're still going to check it, right? Because we want to know. So let's go ahead and quickly go through and check W. We're going to energize that. Nothing happens. We don't blow a fuse. We don't wind up taking and getting major voltage drops. We don't see anything significant that's going on. We don't get amp draws that are exceeding an amp of electricity, so far. And all these are powered in this step. You don't de-energize one and energize them. You want to energize them all. Now at the table, I energized them individually because there is a way you can do that too. But here, we're at the smart board. We're doing this as a step process, and this is a little bit quicker to show you and explain. I can just write it down. I don't have to mess with wires that don't make good connections. Let's go ahead and let's go with O. Let's try O out. Okay, looks like number 4. That'll be O. Okay, step 4 will be O. All right. And then what would step 5 be? Well, simple. Step 5 would be Y. Just like that. Just like that. So let's go ahead and we can write this a little bit more legible. We'll say step 5. We'll go in reverse order. Y. Step 4. O. Step 3 would be W. Step number 2 would be green for fan. And step 1 will be and everything that is just 24 volts. So thermostat, right? Blower control board, right? Defrost control board. So I'm going to go ahead and erase these over here. This is as simple as it possibly can be. So you got to be able to identify your key components, match them up, know where they're located, and in order, how do I get through my short? Okay, just unhook all these, only hook that up. Okay, that checks that off, that checks that off, that checks that off. All right, we just checked off 3 out of 6 things that it could possibly be. Let's go ahead and check the next thing. All right, let's go ahead and put a G-call on there. All right, well, these are still loaded up with 24 volts. So when you add that G-call in, whatever is your G-call, whether it's the board, relay, or module, okay, one is always in circuit. Now there's no point in you leaving 2 out of circuit. Just keep 2 energized. Let's go to 3. All right, kick that on. All right, you're fine. Let's go to 4. Kick on that reversing valve. Okay, if I have a problem, then guess what? You know, I need to come over here and disconnect that and see if it's just in the wire itself. Is it in the wire or is it on the coil? Well, disconnect the coil. We showed you at the table. Disconnect the coil. Is there a problem in the wire? You're going to find out very quickly when you energize it a second time. If it pops a fuse or you get a high amp draw because you're trying to be conservative on your fuse, then you obviously have a problem with the wire, not the reversing valve coil. Okay? If you don't get no amp draw, all right, and you're disconnected, then your wire's fine. Plug it back in. Test it one more time. Make sure you're not seeing things. Oh, if that's the problem, replace your reversing valve coil. Okay? Don't blame that on the control board just because it's coming out of it. Most likely that's your issue, because if you want to blame this, then the moment you disconnect power off the reversing valve coil, all that was still in circuit all the way back to your thermostat wire, then you would have blown, but you didn't. So you got to look at it very simply. Look at the contactor. I could easily pull a wire off the side of that contactor. I'm still going through my board, my pressure switches, and everything else. That's fine. All right. Most likely, you're not going to have a problem until you get down to a source of a load. All right. And so remember this. This will help you get through these calls a lot more confidently and very easy. I know it's a long video. I appreciate your time. The whole point of this is to educate you. We're not done with this series of videos on shorts. We got to just go to that next level. We got to get into more transformers, larger transformers, zone applications, more loads, so we can see what that looks like in a few different perspectives, and that's SmartBoard. Share this with others. That's your job, so you can pass knowledge down. If you can't explain it very well or don't have the time or patience, there's a share button. Hit it, send it to your buddy, teach him. That's how you teach him, right? Serve it to your whole service department. All right. If you're DIY and just trying to understand this because you've had some, service bill that doesn't really make a whole lot of sense, and you're just, hey, whatever I got to do, this fuse is blown 10 times, I need to get up and cooling. Maybe this video is for you too, right? Just be safe, practice safety, don't hurt yourself. We always recommend a licensed contractor. 1, they're insured, right? So that's good. You got to have protection. And 2, somebody on that team is going to have enough experience to get you out of that jam and get your house comfortable. I always say, like our channel, supports the algorithm. When you hit that like, leave a comment or read it. Most importantly, please subscribe. We really appreciate you, and we're here for you. We're not going anywhere. Stay tuned. Stay safe.